Hi everyone, this is Santosh Kumar. Welcome back to our next training. Today we are going to continue explore the assembly workbench.
And next you have move component. Do you want to move components in individual components? Then you can go for move components. For example, I select this component and I want to move it. I can either right click and select it from here, or I can select this and select the move component. So the component has been selected, and specify the orientation. You can specify the orientation of the compass. If you want to move only the compass, then you can check this option, move handles only, so this will not disturb the component and it can move the compass wherever you want. So as of now I'll move the compass to this place. I want it to be particularly facing upward like this. Now once I set the compass, now I'll uncheck this option and now I can move the component over I want. Since it's been constrained, it's already been constrained, that's why it's trying to move all the component that is constrained to it. Let me delete the constraints. Now if I move the component, only that component will move. So if I, as you can see, only the component, and you can move the component how you want. That's the use of this move component command. And here once again you have other options. Do you want to create a copy while moving, or you don't want to create any copy? You can check this option. So that's the use of the copy. And here further under settings you have much more options. If you want to animate, say for example there is a motion simulation which you want to show here, with the help of move component you can make use of these options. For this you have to create arrangements. I'll come to it in the upcoming tutorials. So once you create an arrangement, say for example the vice in the open position and closed position, I'm going to create two different arrangements, and then I can animate it with the help of this option. You can provide the animation steps, the number of steps you want to create. Say for 100 means in 100 steps it would move the corresponding component. So that's the use of this animation steps. And from here you can set the whether you want to apply it to used or use component properties. So those arrangements can be done here. And here you have even collision detections. While doing this motion simulation, if at all it is colliding with any other neighboring component, you can get a warning here, highlight the collision, stop before collision. You have several options here. You can select highlight the collision, so that the moment the component collides with its neighboring component, it would highlight and show you so and so component has been riding over the other component. So that's the use of this collision detection. So all these options are available inside the move component, and I'm going to explain all this in detail in the upcoming videos.
So next we'll be looking into the assembly constraints. So under assembly constraints you have these many constraint options. First one is the touch align, second one is the concentric, third is distance, then you have the fix, then parallel, then perpendicular, align lock, fit, bond, center, and angle. We'll look one by one. So here I have taken the bench wise as an example. Today we'll do how to do assembly of this bench wise. First I'll be making use of the um, touch. Now first I'll touch this face to this face. Now first let me fix this object. Select this. So now if you see the degrees of freedoms, only one degree of freedom, that is translation in this direction. So So I'll make this as 0. So this is the max to which the vise can move. So I have constrain all the degrees of freedom of this vise jaw. Now next we'll assemble these three together. I'll go to assembly constraint. From here I'll select the axis, inferred axis. I want this axis to be construed to this. Okay. And now I want this axis to be constrained to this. It's done. Next, I need this slot to be aligned with respect to this bolt's axis. So I'll make use of constraint, and here you have this type of constraint, 2:1, like this face and this. So now if you see, these two faces are between the bolt. Now that I inserted the shaft, now I have to insert the bolt. For this I'll be using the align lock. This was not there in the previous version. In this version they have given the in the latest versions they have given the align lock. What it can do is it can align the bolt as well as lock the rotation degree of freedom. So that's the advantage of this align lock. So I'll select the axis. So I want it to be aligned to this hole. And it's aligned as well as it is locked this degree of freedom. Now I'll use the touch constraint and I'll touch this face to this face. Yes. Now if you see the bolt's degree of freedom, it will be 0. So its constraint is fully constrained. Let me delete the clip. The clip section has been deleted. Once again for this, and touch this face to this face. Again the same align to this axis and touch this face to this face. See the degree of freedom, it is still showing 6 degrees of freedom. Check the degree of freedom of this. Yes, this object can still move in this direction, so I have to arrest this degree of freedom, but in reality this would be free. I mean, it will be free to rotate, but I will arrest the degree of freedom. Next, touch this face to this face. Then align this hole to this hole. Apply. Now do the same to the bolts. Align lock. Use align lock. Select this axis and this hole. Apply. Once again this axis to this hole. Align lock. And touch this face to this face, this face to this face. And see the degree of freedom. It can rotate, so you have to arrest even the rotation. So touch this face to this face. Update display. Now you check the degree of freedom. Now it's all 6 degrees of freedoms have been arrested. You can even insert the column, the constraint column, that is. Yeah. So I have created the position column. This will tell you whether the component is fully constrained or partially constrained. As you could see here, the vice body is like fixed, that is this, the top first body, and the second body is fully constrained. If you see a complete dark circle, that means it's fully constrained. These are all partially constrained. As you can see here, it says it's partially constrained. Once again, these are all fully constrained. Why I kept this one as a partially constrained in the sense this would actually in reality it will rotate. So once this component rotates, this jaw wise would move forward. So I kept it as is. I kept only the rotation degree of freedom. As you could see here, check the degree of freedom. It still rotates in about the x-axis. So that's the reason I retained that particular degree of freedom. So if I rotate this, if I rotate it, so this is how in reality it will rotate, and the screw wise would move forward. So that's so you can control the jaw's position with the distance constraint which I have used. So now if I give a value to it, the jaw will move to and fro. So 40, 30, as you can see here, the jaw moves according to the value that you specified. So I'll make it to the 0, and it can also rotate above this axis. So to hide the constraint and to hide all this constraint, you go here, right click and select display constraint in graphic window. If you uncheck this option, it will not display. And the second is for suppress constraint. Sometimes if it is like over constraints or the constraints have been suppressed, you can check this option to hide those suppressed constraints. So that's about the constraints. Now let's quickly see what this each and every option do here. Let me delete all the constraints. So here we have seen touch, align, and center axis. We have seen all these three constraints. Next we'll see concentric. Concentric is you want to constrain any object concentrically, then you can make use of concentric constraint. I want to make this concentric to this axis, then select the constant constraint. Yes. So now it is concentric. Next, distance constraint. This way I can give value and constraint the distance constraint. Fix is for fixing any component you want to fix. Parallel is you want a component to be parallel to another component, then you can use this parallel. I want this face to be parallel to this face, then I'll use the parallel constraint. This face, as you can see, it makes the face parallel to the other face. That's the use of parallel constraint. Once again, perpendicular is the other way around. I want this face to be perpendicular to this face, and I will use perpendicular constraint. Sorry, first you need to select the object that you want to move, so I'll select this and this. Now it's perpendicular constraint. Align lock, as you know, for this is majorly used for the bolts. You want to lock the rotation of the bolt, then you use align lock. And this is fit. Fit is useful when radius is same, it will be applicable. For example, I can't use it since these two radius are of different radius. It will give you a warning symbol. See, it's showing you in red color. That means you cannot fit this shaft inside the hole. So only when the radius is of equal dimension, only then the shaft can be fitted inside the hole. That is the use of this fit. Fit constraint constrains two objects with equal radii, such as circular or elliptical edges, or cylindrical or spherical faces. So that is when this fit is being used. So if you have a ball on the socket joint, that time you can make use of this fit constraint, provided the balls and the sockets radii is of same value. And bond has been used for weldments. Say you want to weld two components together and you want to show that component as a single entity, then you can use the bond constraint. So what this does is, initially if you see, if I move this, only that component will move, but once I made use of the bond and I bond these two things together, so now if I move, they both will move together. So bond is actually used for weldments. So if in case of weldment you want to weld two components together, that is when you will be making use of bond constraint. Next, this we have seen center line, and the next, angle. You want a component to be constrained at an angle, you can make use of this angle constraint, and you can specify the degrees here, to what degree you want it to be constrained. In such case you can use the angle constraint. So that's the use of angle. Then next we have show and hide constraint. Once you go to show and hide constraint, it will ask like visible constraint between components or connected to components. So between components, I want to know all the constraints that is constraint between this component and this component. Then I'll use between component, apply. So I think these are the three constraints four constraints available between those two components. So this way you can see what are the constraints between two components. That is the use of this. Next you have connected to the component. If you select the connect to the component, so you select this object and click apply, you will be able to see all the constraints of the component that is connected to this particular component alone. So alone you will be able to see what are all the constraints constrained to a particular component. So that's the use of connected to component and between components. So that's the use of show and hide constraints. And then next you have remember constraint. Remember constraints is useful when you want to remember a similar kind of a constraint. Say in the here in the bottom you have two bolts, but as you can see here I constrained it individually. Initially I gave an align lock to this bolt and touch the bolt to this face, and again once again align lock this bolt and then touch the similar bolt to the face. But if I can remember these two constraints for one bolt, I can do the same to the other bolt with the help of this remember constraint. I will illustrate like how to do. But for doing this you should have the right access for the particular bolts, so that the constraints will be remembered in the bolt. Because for a particular bolt, since you want to remember a constraint for a particular bolt, you need to have a right access for that. That is one limitation. So if you don't have a right access, then this constraint will not be remembered, and you may have to do it separately alone. So let's see how exactly this remember constraints work. So let me delete these constraints. So this is the component, and these are the constraints which I need to be remembered. I'll select OK. Let me delete it. So now I will add the component. So it's giving you an alert here. It says that the selected components have remember constraint defined. If you do not constrain these components, then the inputs for the remember constraint can be defined after OK. So here you can change from initially it will be move, you can toggle it to constraint and select OK. So here the redefined constraints would pop up. This is the remember constraint. So the first one is align lock. Align lock the particular bolt. Align lock it to this axis. So it's align lock to this axis. The first constraint is, and the touch, I want to touch it to this face. So once I click OK, I'm not able to see the bolt. Yeah, it's hidden. Yeah, as you can see here, it's automatically constrained with the constraints that I previously used on this bolt. So that's the use of remember constraint. Next you have show degrees of freedom. Degree of freedom, either you can right click on a component and you can select it here, or you can select the component and you can select the show degree of freedom. Degree of freedom will show you what are all the degrees of freedom. As you can see, this has been fixed constraint, so it will have 0 degrees of freedom. So I'll select the component. As you can see, it's saying there are no degrees of freedom. So that is what it says in the bottom here. Now as you can see, for these components I didn't constrain it completely. These are all partially constrained, as you can see here. So you can, if you want to see the degree of freedom, you can select the component. See, so as you can see, the rotation degree of freedom is still not constrained. Similarly for this one, you select this component, you want to know what is the degree of freedom that's not constrained, select the degree of freedom. As you can see, once again here the rotation degree of freedom is not constrained. The third one is the bar globe. For this one, once again the rotation degree of freedom is not constrained. See, so it says that the rotation degree of freedoms are not constrained, which I intentionally needed. I want this bar to be rotated, so that's the reason I didn't constrain it completely. So that's the use of this degree of freedom. So this completes the tutorial on component position. So if you like this video, hit that like button and share max. Until then, bye. Santosh Kumar signing off.